Hello learners, this is Education Online program and our subject is chemistry and the topic is one of the physical properties of group 7, which is the boiling point and the melting points of group 7, which are the halogens. So it means here, as we talk of the boiling point and the melting point, it is a special case whenever you deal with any other group. So the melting point and the boiling points, they differ group wise. As you have from group 1 to group 7, all of these groups, they have their boiling points differs because they belong to different groups, and they are different elements or types of elements. Some will be metals, some will be non-metals, and others are known as the noble gas or the inert gas. So the boiling point and the melting points of group 7 here is it shows that it increases as we move down the group. So we know the elements that constitute group 7. So the group 7 elements are fluorine, we have chlorine, bromine, iodine, and we know the last one is acetylene, but it is a radioactive element. So the melting point increases down the group. The melting point increases down the group. So it means here we are going to see that the melting point for fluorine is the least compared to the rest of the elements in the group. So it means the highest melting point and the boiling point will be for iodine, and the least will be for fluorine. So we are going to see that this is due to the increasing strength of the van der Waals force. So there is increasing strength. So this increase in the melting point and the boiling point is due to the increase in the what is known as the van der Waals force. And here this van der Waals force increases as you move down the groups. Why? Because the force or the bonds in each element from group or from the first element, which is fluorine, to the last element, which is iodine, is much harder to break. That is why it has to this van der Waals force has increased, and it means the melting point has to increase, and also the boiling point has to increase. So in this case, the force is responsible for the trend in the changes of the physical state. Also here, this force, which is known as the van der Waals force, it is responsible for the physical state of the halogens. So it means here this van der Waals force is very important, and it affects the melting and the boiling points, and also it affects the physical state, and its effect is seen in the changes of the physical state of these elements. So we are going to see how to the values of these elements changes as we move down the group. So we shall have to see that the first element, which is fluorine, is having the melting point. Let me put here elements. Then we have melting point, which is in degrees centigrade, boiling point, which is also in degrees centigrade, and we have the color of these elements and the physical state. So we are going to see the changes which is brought about through what is known as the van der Waals forces. So the melting point for the first element, which is fluorine, we know that the boiling point and the melting point, it increases with the increase in the van der Waals, the strength of the van der Waals force, and this causes also the changes in the physical state. So we have fluorine, which is the first element, and it has the symbol F, and its melting point is -2 to 0. And the second element, which is chlorine, it has a melting point of -1, 2, and bromine, which is Br. Let us write it in symbols. Br, it has -7, and iodine with the 1, 1, 4. So if you are seeing that the first element will have the least boiling on the melting point, while the last element, which is iodine, will have the highest value of the melting point. So here we are going to see that with the boiling point is 188, and it is negative sign, while for the second element, which is fluorine, will be 35. The third element is 59 positive, and the last one is 184, also positive sign. So in this case, we have seen that the boiling point and the melting point increases as we go down the group with the highest boiling point and the melting point of iodine. So the least boiling point and the melting point will be for fluorine. So we are going to see the colors. So the colors also differs. This is due to the increasing strength of the van der Waals force. So we are going to have the pale yellow color, pale yellow, for the first element, which is fluorine, and then followed by pale green for chlorine, and we have red brown for bromine, while the last one is black in color. So here this also shows, or it is affected by the presence of the increasing strength of the van der Waals force. We are going to see also the state or the physical state of these elements, as it is much connected to the boiling points and the melting points. So we are going to see the first one is a gas, the second one also a gas, the third one is a liquid, and the last one is a solid. So iodine is considered to be a black solid, while bromine is considered to be a red brown liquid, and chlorine is considered to be a pale green gas, while fluorine, the first element, is considered to be the pale green, pale yellow gas. So they all have different physical state depending on the effect of the van der Waals forces. So we are going to see the chemical properties of these various elements. So we are going to see the reactions of these halogens with water. So what happened when they reacted with water? So reaction of halogens with water. So reaction of halogens with water. What happened when there is a reaction, or when this one of these elements come in contact with water, or when you put water inside a container, or that is what we call as a beaker or as a conical flask. So you join water with one of the elements here, one of the halogens. What will be the results? So we're going to see the first element, chlorine, when it is dissolved in water, turning blue litmus to red, and then forming green yellow solution. So you can have the first element, which is chlorine. So chlorine here, when it is dissolved in water, it will have to show some colors. And here we are going to say that chlorine, when dissolved in water, it will turn blue litmus paper to red. So learners, if you have blue litmus paper turns from blue to red, it means there is an acidic solution. So in this case, we are going to see that when chlorine is dissolved into water, it forms it has the ability to turn blue litmus paper to red. It means the solution become acidic. And in this case, we have seen that with the turning of the blue litmus paper into red. So we are going to have, again, this after forming, it will form forming green yellow solution. So you will see that this solution, which is formed from water and chlorine, it will have a green yellow color. So this solution will be having this color, which is green yellow, and it is showing the presence of chlorine gas in that solution, and the solution is acidic in nature. So we are going to see that both hydrochloric and hypochlorous acid are formed in the solution. So the presence of this acidic solution is actually brought about the presence of hydrochloric acid and also a weak acid, which is known as hypochlorous acid. So we are going to have chlorine when it reacted with water, chlorine gas when it reacted with water, or let me say it is a solid because we dissolve it in water, it will have this formula. And when you join water molecules with the chlorine molecules, we will have hydrogen or hydrochloric acid, and this hydrochloric acid is in aqueous form. So hydrochloric acid plus hypochlorous acid, and this one also is in aqueous solutions. So these solutions are actually acidic. That is why it turns the blue litmus paper into red, and then forming the greenish yellow color of the solution. So also we are going to see that the dye, because here chloric acid has bleaching property, and it bleaches both red and blue litmus papers. So the solution first turns blue litmus paper to red, then bleaches out. So this solution here, we consider it as a dye because chlorine has the property of the bleaching. It means it bleaches some colors out. So maybe you'll have a yellow color and it bleaches to a colorless color. So it means chlorine has the effect or the property of bleaching some properties. So in this case, we have dyed with the hypochlorous, which is one of the products. When you dissolve chlorine into water, we will have hydrogen chloride plus dye and oxygen. So this last product here is actually the colorless product. So we have this become colorless because it has been bleached with, this one is a colored one, the dye is a colored, while when it is affected with the one of the chlorine products, it returns to colorless. So it means here it has been bleached from that colored substance to a colorless one. So this is actually the property of chlorine molecules or chlorine gas. So we are going to have also the reaction of bromine liquid with water. So what happens when we have bromine liquid when dissolved in water, dissolved in water what happened to it? It is, we are going to have the same, it is related to the same reaction here of chlorine with water. Why? Because they are all halogens, and we have seen that we have not started with the fluorine. Why? Because fluorine is the element which is least reactive among the highest reactive among the halogens. So in this case, we are going to omit fluorine. Why? Because it is the first element in the group and it is the smallest one in the group, and it has some other properties: highest ionization energy, highest electronegativity, also highest reactivity, and all this. So it means here we are going to deal only with the following three elements in the reactions. So the second element here will be bromine liquid dissolved in water to form, it will form also acid, to form hydrobromic acid, and also hypobromic bromous acid. So hypobromous acid. So in this case we have a weak acid and a strong acid formed from bromine. So we are going to have the reaction, and it will actually, the resulting mixture will be orange. So also it will form an orange solution, orange, yellow, and has acidic and bleaching power as we have for chlorine. It means here when you react bromine, it will be the same reactions as we have in the one of chlorine. So when you react bromine with the water, it will form hydrobromic acid and hypobromic acid. So we have the reaction of bromine liquid to dissolve in water to form hydrobromic acid and hypobromic bromous acid. So you can have also iodine. So iodine, when it reacted with water, it is insoluble in water. It's insoluble in water, and resulting mixture is a brown color, a brown solution. So in this case, we are going to have that the iodine, although it is insoluble, but the amount that has dissolved will turn the liquids into brown solution. So we are going to have a brown solution formed from iodine, and fluorine react with water to form hydrogen fluoride and oxygen gas. So in this case, we are going to have iodine, when reacted with water, it will not all get dissolved, or it will not dilute all, and it will form the resulting mixture will be brown, and it will form hydroiodic acid plus hydro, and in the reaction will be like that one. So in this case, we have the reaction of bromine liquid dissolved in water to form hydrobromic acid and hypobromic acid, and the reaction will also look as, we are going to see that the water will be orange yellow, or the solution will be orange yellow, and the reaction will be bromine reacting with water. It will give us the acid, which is a strong acid of bromine and weak acid of bromine. So here we are going to have hydrobromic acid plus, which are aqueous in this form, or the physical state will be aqueous, and we are going to have hypobromic acid. So in this case, we are going to have a weak acid of bromine and a strong acid of bromine. The same thing for iodine here, although it is insoluble, but still it will form a strong acid and a weak acid of iodine. So we are going to see that the reaction of group 7 with the water is very important in forming either the weak acid and it will form both the weak acid and the strong acids. So we are going to see that fluorine, although it is very strong, or it is more reactive than the rest of the elements, but still it is reacting with some other reagents. So in this case, fluorine, when it reacted with the water, it formed hydrofluoric acid and also oxygen gas. So in this case, we shall have the difference here is fluorine, it is highly reactive. So when it reacted with the water, it will form one of the product as oxygen. So we are going to have chlorine gas plus water, which is a liquid. It will give us hydrogen, chloric acid, and we have it as aqueous, and then oxygen gas is liberated. So in this case, the difference is we are going to have oxygen gas in the with the first element because it is highly reactive compared to the rest of the elements in the reactivity series. So we are going to see the reaction of chlorine with the alkaline solution. So reaction, and the reactivity, as we know that it decreases as we move down the group. It means the reaction of chlorine, it is more vigorous. Of chlorine with the alkaline solution will be more vigorous compared to the rest of the elements in the group. Alkaline solution. So the reaction of chlorine with alkaline solution. So chlorine react with the cold dilute sodium hydroxide solution to form a yellow solution of sodium hypochlorite and sodium chloride. So we are going to see that sodium, let me say chlorine gas, when it reacted with the cold dilute hydrochloric sodium hydroxide, it will give us sodium hypochlorite and plus sodium chloride, and then the other product is water. So water here is one of the byproducts when there is reaction of chlorine with one of the alkaline solutions. So in this case, we shall have chlorine plus sodium hydroxide. 2 molecules of sodium hydroxide will give us sodium hypochlorite plus sodium chloride and water as a byproduct. So chlorine react with the hot concentrated hydrochloric sodium hydroxide. Here we have this one is dilute cold solution of hydrochloric acid, and when it reacted with this one, now in this case is the hot one, it means the concentration is a concentrated solution of sodium hydroxide. So here we are going to have sodium hydroxide, 6 molecules, will be giving us this solution, which is sodium chlorate, sodium chlorate and 5 molecules of sodium chloride, which is aqueous, plus 3 molecules of water, which is a liquid. So in this case, we shall have 3 molecules here formed, and these products are sodium chlorate, sodium chloride, and water. So we see that this is now a hot concentrated alkaline solution of sodium hydroxide. So we are going to see that the reaction of chlorine with the alkaline solution is divided into 2 ways, and here we are going to see that first it reacted with the dilute called sodium hydroxide. Secondly, then it reacted with hot concentrated sodium hydroxide. So learners, we took chlorine as one of the representative for the 3 elements which follows fluorine, and we know that as chlorine reacted with the sodium hydroxide, the same thing bromine will react with sodium hydroxide, and also iodine will react with sodium hydroxide to give us the resulting products, which are sodium hypochlorite plus sodium chloride and water. The same thing will give us sodium hypobromate and sodium bromide, and also we have water. So in this case, chlorine is taken as an example to show that the reaction can be in such a way, and we know that there are going to be three products when react the hot concentrated alkaline solution and the cold concentrated alkaline solution, which is now sodium hydroxide taken as an example for all the other elements. So learners, we need to remember that the reactivity of group 7 decreases as you move down the group. It means the first element decreases from top. The first element is the least reactive as the highest reactive compared to the last element, which is iodine, and we consider it as the least reactive. So it means if you want to react iodine with any other reagent, you make sure either you increase the reactivity by either boiling or heating the reagents, at least to have a reaction in a speedy way, or you can have activator, or you can have something to speed up the rate of the reaction, and this we call it as a catalyst. So either you add a catalyst to speed up the reaction, or either you heat the reagents or the reaction to proceed. At least you need to heat it, and it will increase the temperature and the reaction will proceed in a normal way. So learners, you need to remember the reaction of these halogens with the water, the reaction of halogens with the alkaline solution, and this will give us the view or how all these reactions takes place. So we need to remember all them, and we need to know that the products which are given and the product which are given in each reaction should be known for the rest of the elements in the group. So group 7 is one of the groups in the periodic table, and it consists of 5 elements, and these 5 elements are fluorine, chlorine, bromine, iodine, and astatine. The first 4 are considered to be non-metals, and the last one is a radioactive element, which is astatine. And astatine, because it is a radioactive element, it is treated separately, not in the same place with the rest of the elements, which are non-metals. So in this case, we need to remember that here we did not touch astatine because it is a radioactive element. So group 7 also are considered to be halogens because they are salt formers. So if you see from this reaction, we have seen that there is sodium chloride, and sodium chloride here is considered as a salt. You can have sodium bromide also as a salt. You can have sodium iodide as a salt, or potassium iodide, potassium chloride, potassium bromide as a salt. So here in this case, we consider the noble gas as the salt formers. So they form salt, and they are the only elements that can form salts in such a way. So we have also to remember that the group 7 elements, they can form anions, and these anions, they form it by gaining a single electron to complete their outmost shells. So the outmost shell is completed by adding a single electron. So when you add a single electron, it will form an anion, and this is whereby you have fluorine atom. When you add one electron into its outmost cell, fluorine atom will turn into fluoride ion. So the same thing with the chlorine. When you add a single electron, it will turn from chlorine atom to chloride ion. The same thing with the bromine and iodine. So in this case, you will have they will have 8 electrons in the outmost cell, and we consider them having a complete outmost shell electrons. You need also to remember that they are known as diatomic molecules. So they are not found in free state. They are found in nature as in free state, and they are actually known as diatomic molecules at room temperature. It means they should have 2 atoms of chlorine joining together, and this is joined by what is known as a covalent bond. So a single electron of this chlorine with the other one will join together to form a covalent bond, and this makes them to behave as a diatomic molecules. So they will form a diatomic molecules. So a diatomic molecules, and in this case we consider them at room temperature. So at room temperature they form a diatomic molecules by combining two single atoms together. So learners, we have come to the end of this lesson, which is the chemical properties of group 7. Till we meet next time, thank you for watching.